Okay, so what we're doing when we move in and select a new dredge site is we use the existing data that we have for a region. And over here in Hess Rise and into the Liliuokalani Seamount chain, we have a combination of the satellite altimetry data, which produces some low res, like a predicted sort of bathymetry that gives us a general idea of what kinds of features we're looking for. So when we see shapes like this, we figure there's probably some sort of a seamount or other volcanic structure or platform here. And we can use some of these gravity highs and lows in order to figure out about where we want to come in and map a feature for a site that we can dredge. And where we start that waypoint, that depends a lot on things like what sort of prevailing currents we have, what the winds look like in the area, and what the ship can do with the combination of those wind and surface water conditions. So using what we know about the regional sea conditions, I am picking spots normally on the western sides of the seamount so that we can dredge from east to west generally and adjust that angle as needed for the exact conditions in that area and at that time of day. So I pick a waypoint uh, where I think I'm going to be able to get a range of possible headings for the ship to work with, and I'll drop in on that point and I'll start mapping. In this case, since we're heading this way, generally across the whole track, back towards Honolulu, um, I'll start at the north end, and once we hit the waypoint, we'll slow the ship down so that we can map at higher resolution, and we start mapping south along basically a bathymetric contour or a range of depths where we can see the kinds of features that we're looking for and that look like they'll successfully be dredged and bring up a payload of samples. So this is a seamount that we just started mapping at. We just got into a waypoint in this area, right about here, and we slowed the ship down and we asked the bridge to turn the ship to a southerly heading, heading of 180 degrees. And we're going to map a little bit south and then turn to the southwest and map along this flank of the seamount and try to set up a dredge to go somewhere generally west to east along the seamount. So there's a little bit of map data that you can see already that shows that this has some interesting features. So that helped me pick a spot to start. But when it's all gravity data like this, I'll start with what the orientation of that anomaly looks like and try to map along an area where it looks like we'll have the best chance of finding some headings that work.
Okay, right now we are just uploading the data in real time from the Echo Sounder to Chimera. This is the line that we're going to be working in the spot that is interest for our dredge. What the software does is to append or create a new station depending on what we want right now. In this case, we're going to create a new dynamic grid to this area because it's the area of interest. So we create a dynamic grid in Chimera with a suggested sail size or the grid. Right now we're in a depth between 4,000 and 3,500 meters. So we create this grid and it automatically creates this surface. But we need to clean this data because it's like rough data. So we open the swath editor and we start seeing in this lower part like some noise that is going through the through the bottom. So we just like clean some data around it. It's gonna make like some general zoom. This is gonna be a little bit fast. For the example, we delete the excessive or the points that are out of the normal cloud of points that should be in the software. Once you clean all the data, save the grid and it will update the grid with new characteristics, generating a 3D view with the segments we are working on meanwhile.
So right now we're mapping the seamount. This is a lot of interesting features to it. It's got pretty much everything we're looking for. It's got these steep slopes, some in excess of 35, some cases even over 40-degree slopes, which are above the angle of repose. And those are cliff forming faces, so those are really good for us to drag a dredge up because we know that there's good rock from the interior exposed there, and we can really bite on that with a dredge. One of the other things we're looking for is a really strong backscatter that you can see in the raw data, and we'll process some of that later and take a look too. And if we see really bright returns, really strong reflections in the backscatter, that tells us that that's probably hard rock that we want to sample. It's not hard rock isn't the only thing that is going to give us a really strong backscatter, because sometimes that's carbonates too, but carbonates don't necessarily form the same steep slopes as what we're looking for the hard rock. So the combination of strong backscatter return, steep slopes in the bathymetry, that's what we're looking for. And with that, we should be able to get a pretty good payload once we find the right angle and the right approach, the right length track for us to take a dredge down and move along. All right. So this is some of the data that Caesar just cleaned up that we just mapped within the last 20 minutes. And there's some really interesting features in here that I think might dredge really nicely. So we're looking at it, if we were to look straight over the side of the ship and look all the way down to the seafloor, this is the kind of features that we would see. So this is map view, but what we really want to do is check out the profile of this, because that vertical profile is what the dredge will see. And the things that we're looking for when we actually go and pull a profile that looks like it might work for dredging is go into a profile tool. We can look at a couple of different things here. So for example, this profile is really good because you have some steep slopes. So right here, this maxes out at almost 44 degrees, and it's pretty steep all the way up, and that's above the angle of repose. So that tells us this is probably a little bit of rock that's exposed. That's really good for us to put a dredge down on and try to capture some relatively well-preserved in-place rocks and break them off of that slope. It's also right in the middle, which makes it easier to set up a dredging strategy, which all the dredge technicians have been working on. And then we can kind of pull up and over this and go back up where it gets steep again. And you're still getting some pretty steep slopes, some over 34, almost 35 degrees and up 20, and then it'll kind of flatten out. We get back on top of second terrace, and that'll be closer to the end of the dredge. So this one looks pretty good, and we might actually run with it.